Okay, so I'm going to try to jump um, ahead a little bit with to jump over a lot of complexity and just make a point in this video. First of all, we need to define distribution. Um, Distribution is whether or not a proposition distributes, well, whether or not it distributes its term. What it means by distribute is, does it assert something about each and every member of the class that it's talking about. Now here with the subject term, that's actually going a little farther than I probably want to. I'm just going to talk about terms in general and look at the distribution patterns. So for the A proposition, this will just bear with me for a minute. This is saying that the A proposition is saying something about each and every member of its subject term humans, but it's not saying something about each and every member of its predicate term mortals. Now if you look at the diagram up here, you can see that we're saying that all humans are mortals. We're saying something about each and every member of the term humans, but we're not saying anything about the rest of the mortals out here. These we're not actually including in our consideration. These we're not saying anything about. Okay, so it's a non-symmetrical distribution pattern. It distributes the subject but not the predicate. Now, on the E proposition, you can see that the subject and the predicate are both being distributed. No humans are immortals. So we're saying that each and every member of the class of humans is outside the class of immortals. And each and every member of the class of immortals is outside of the set of humans. So the E proposition is symmetrical. It distributes both its subject and its predicate term. Now, in the I proposition, we're only talking about this wedge, this intersection right here. We're not talking about any of these guys here or any of these guys here. We're only talking about an intersectionality. And so it might be all of these, it might be all of these, but, well, actually for humans, it's saying some humans. So we can tell that we're not talking about all humans, we're only talking about a subset of them. But when we say some humans are Jamaican, we don't know if we're talking about all Jamaicans or not. Because we're familiar with the class of Jamaicans, we know that, we could say all Jamaicans are humans, and that would put them all inside here, but we're not, right? We're saying some humans are, that's the subject, and they're inside the class of Jamaicans. Okay, and then the final, so those are not distributing either the subject or the predicate, and that is also symmetrical. And finally, we're looking at the subject in the O proposition, where we're saying something about every member of the predicate term Jamaicans, but we're not saying something about every member of the subject term humans. We're only saying some humans. And if you want to look more at distribution in these cases, you're free to do that. Really, that's not so much the point. My point is to say that is to take a look at this inference conversion. Actually, I should renumber these because these are other inferences in addition to the first. So this would be like number 4. This would be number 5. This would be immediate inference number 6, and this would be immediate inference number 7. So I want to just take a look at one of these, conversion, as it relates to distribution, and discuss distribution, how it plays into how these inferences work or don't work. So what I want to say is that because these are symmetrical, that's why conversion works for the I and the E. You see the I and the E are both symmetrical, and here you got conversion working. Well, the reason that conversion works is, let's say the reason that it doesn't work for the A proposition is because in the A proposition we're saying something about every member of the class of the subject term, humans, but we're not saying something about every member of the predicate term, mortals. And yet what conversion requires us to do is move the predicate term, which we're not saying something about every one of them, and move it into a position where we're trying to say something about every member. And that can't work. These are not symmetrical, so you can't move them over. And by the same reasoning, we're trying to take something here where we're saying something only about some of this class of humans and trying to move it over into a place where the distribution pattern requires that we say something about every member of that class. So if you only have information about some members, you can't just automatically flip that and try to make claims about every member, because you only have information about some member. And that's why the distribution patterns won't work, and you can't trust that the truth value of this term will be the same when you flip it, when you convert it. You can't trust that the truth pattern of this will be the same when you convert it. It's because of the distribution patterns. But because these are symmetrical, you're saying something about all and you're saying something about all, then you can reverse them without loss. And because these are saying nothing, they're not saying something about every member, either the subject or predicate, you can flip those without loss. That's why those work. Now, so the point is that the reasons why these, we don't have to go into why this works and why this works. And we don't have to go into why contraries and subalternates work or don't work. But we can talk a little bit about the patterns generally. For example, contraries are where the A and the E proposition are in opposition in some ways, but not in every way. So for example, both of them are universal, but the quality is different. I should actually mark this as red because that's different too. The quality is different. And the distribution patterns are also different. So here they are, they're different, the A and the E. So the inferences that you can draw from them, one of them is that contrary statements are both false. They can both be false, but they cannot both be true. And we could take time and we could discuss why that's the case because of these patterns. Contradictory terms are extremely important. What you see, they differ in every way. The quality, the quantity, and the distribution is different, so that's why they're contrary. They're opposite truth values. All humans are mortals. Some humans are not mortals. Okay, so they're different in every way. Their distribution pattern, we're looking at their distribution and their quantity and their quality are all different, and that's why they're different. So the law of contradiction is dependent on this immediate inference. If we have to give up on some of these other ones, maybe we have to, but we cannot give up on this one. And we're going to discuss that a little bit more later. So a lot depends on it, right? We don't have to go into inferences that we can get on subcontraries. Basically, they can both be true, but they can't both be false. Contraries can both be false, but they can't both be true. And so you can see by the contraries and subcontraries that we're having a relationship between this and this. And it's a dependent relationship. This is the primary inference, and this is a dependent inference. There are also alternates and subalternates would be a dependent relationship of the alternates, where basically it's saying that if the universal is true, the subalternate also must be true. So if all humans are mortals, then some humans must also be mortals, right? That's the subalternate. So the point here of all of this, without getting way off into the weeds, is I did want to show you very specifically about conversion, but we don't have to go into the real details of all of these. It would take some time. But my point is that there are rules here. These rules are the foundations of reason. They're the foundational checks and balances that are placed on how we process our observations of the natural world. And the question that I have to ask myself is, what are the implications that these rules exist on the conceptual level, but that we didn't invent them, that we have to learn them by observation of the natural world, that these rules are present in the relation sets, the relationships between sets that we find everywhere in nature, and that they're not obvious, actually. They're elegant, and they're very logical, they're very systematic, but they're not obvious. We are taught them when we interface very carefully with the natural world. And what I have to do with my own thinking is ask myself the question, interpretively, what does this imply?